The first thing we want to note at the beginning of the video here is that the acyclic enhanced mode has not always been a function of these AL2 hubs. It was not until the hardware revision BB or higher that this functionality has been included. So keep in mind the AL2605, 2205, they need to have on the right side of them HW for hardware revision BB or higher in order to use this mode. Thank you, and let's begin. Okay, so to start out with, we're going to take a look at changing the AL2605 from the factory default of cyclic mode into the acyclic enhanced mode. To do that, currently we need to have the LR device software, and we need to connect up to the master it's connected to and make sure that we have it connected to the master. Then we need to go into the vendor section here in the offline mode, select IFM, AL2. We're going to find our AL2605 part number, and it will say Acyclic Enhanced. We're going to select this. Now we have the IODD profile loaded in the software, and the simplest thing to do next is just come up to Write to Multiple Sensors, click on the AL2605. This, we can see here, matches up with the master I have connected already. And we're going to click on OK. That is going to push that profile to the hub. And from there, we can configure our operating modes for pulse width modulation, which is what we'll take a look at in the video today, or analog signals in, digital ins or digital outs. What we need to keep in mind in regards to the data mapping is currently there's no add-on instruction, but even if we had an add-on instruction for Allen Bradley, there's not going to be an add-on instruction most likely for Brown or Automation Direct or other PLCs. So what we need to do is we need to find the AL2605 datasheet on ifm.com. When we get to the datasheet page, you scroll down to and click on Downloads. And if we scroll down a little bit, we'll get to a section that says IODD Downloads. We don't want the IODD files themselves. We actually want to take a look at this PDF document for the Acyclic Enhanced. And when you pop into that document, we'll see here the data format for the input array, the output array, and we're also going to find a lot of other information about indexes. But let's simplify that. Let's just take a look at the output data because we're looking at doing pulse width modulation today. So here on the left-hand side, we're going to see the description for the data on the right. What you'll see is that there's a section with a little asterisk next to it saying for port 7 mode and for port 8 mode, the digital output bits, these bits in the dark blue section here, those are going to activate the pulse width modulation of mode 7 and 8. So mode 7 and 8 here have to be manually set like we went over and via the software for the hub. And then the value, whether it's 0 to 1,000, which is 0 to 100.0% duty cycle, or the 0 to 2,000 milliamp value for the pulse width amp signal, has to be put into these purple data points for ports X10 through X1.7. If we take that PD out array from the document and we line that up with our integer array for the output in the PLC, we can then move forward in the next video on how we need to fill that out and show some examples.